today let's solve the problem number 136, single number, right? So let's see what the question states here. We are given a non-empty integer array nums. You can clearly see here we are given a non-empty array integers nums where every element appears twice except one. So every element appears twice here except one element, right? So we have to return the single element that appears only once. See here, this one. Here in this case there is there is one element that appears only once. We have to return that one element itself, right? So what is the constraints here? So linear runtime, nothing but big of n, and the constant extra space, that is nothing but the space complexity big of 1. We have to solve this one with big of n and big of 1 basically, right? And we can just make use of the bit manipulation, right? So to solve this particular problem, so we will be making use of the bit manipulation. Just remember this one, right? So I'll just write here MNP, nothing but the bit manipulation here. So again, so we'll be making use of the bit manipulation XOR to solve this, right? So let me delete this one. This is fine. So we have 2 to 1, 2 comma 2 comma 1, and this one. Output that we need to get here is 1, because this is duplicate. Every element is this one. For every element we have duplicate, and there is only one element that will not be having the duplicate. That element we have to return, right? So in this case we have to return 1. So that's what they have done here. Same goes with the example 2 as well. See here we have 1 repeated, 2 repeated, we have 4 that is not repeated. It exists only once in the array, so we have to return that 4. Same goes with the example this one, basically example 3 as well, right? So just give me a second here. Yep, see here we have 1 and output is nothing but 1. So we have only one element which is which doesn't have the duplicate. We can directly this one, do this one, what do we call, return that element itself. This is fine. Now as I have said, let's do one thing. Let's discuss the approach followed by the complexities, and then let's write code. As usual, let's discuss the approach first. First of all, I have already said that we will be discussing the bit manipulation, right? So this is fine. So now let's go with the XOR facts, right? So let's go with the XOR facts. First thing, let me tell you here. So A XOR A, so this one is 0, right? So A XOR A, this one is 0, and 0 XOR A, this one is also 0, right? So this one is also, sorry, 0 XOR A is A, not 0. Sorry, this is fine. Now one thing I would like to tell you here is XOR is either this one, cumulative or associative, right? So it is cumulative as well as the associative. Just remember this one, right? So if you know the XOR table basically, so suppose if we consider this one A, B, and this one, let me consider this one as a result. So only when it is odd, then it is this one, true or 1 basically. See here, 1 1, let me go with 0 1 1 1 0 as well as 0 0. Only odd in the sense either it has to be 0 1 or 1 0, then only it is 1 basically. So this one is 1, this one is 1, 1 1 is 0, 0 0 is also 0, right? So let me this one, let me scratch these two. So only when 0 1 is 1 and 1 0 is 1, this one, just remember this one, right? So A XOR A is 0, 0 XOR A is A, as I've said. This one XOR is either cumulative or associative, right? So this one, first we have so accordingly with the approach we'll be going with the result variable. Let me consider result variable res. Initially result variable will be set to 0. When we start the iteration, the first element that we have got here is 2, right? So this one result, we will perform XOR. Result equals result plus this one, result plus XOR of this one, 2 basically. Result XOR equals 2 we will be going with basically. So result will be quite obviously 2. Result will be 2. Next let's go with the next step. So this one result again, XOR, result XOR equals 2 we will give. So this time result becomes 0. Why the result becomes 0? So just remember, opposites, duplicates cancel basically, not opposite, sorry, duplicates cancel. So we will get the result 2 itself again. So 2 is already present and duplicate cancels here, 2 and 2 cancels here, right? So 2 and 2 cancels here. So the output that we get here is 0. Result is 0. This is fine. For the second one, result becomes 0. right? Next we have the value 1 basically, right? So the third iteration we have went with this iteration, third we have 1. So this will be result equals 0, result equals we have to go with XOR, right? XOR result equals 1 basically, right? 1. Now during the third iteration result becomes 1. So we have this one only once, right? So result, I'll just write here 1, right? So final result would be 1. Final result would be 1, which is the single element. Final result equals 1, which is the single element. So single linear pass with XOR yields the answer. Final result is 1, and the single linear pass with XOR yields the answer, right? So the output here would lead to 1 basically. This one again, final result is equivalent to the 1, which is a single element. So single linear pass with XOR yields the answer. The output that we got here is 1, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here. Our approach works absolutely correct. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what would be the time complexity here? The time complexity would be big of 1, right? So because we are going with a 1 pass through the array, right? So just give me a second here. So the time complexity would lead to big of n, as I have said, due to 1 pass through the array, and also the space complexity would lead to big of 1 as they had. So this is one of the criteria they had asked in the question to solve with on big of 1 and big of 1 basically, right? So this is fine. So the space complexity would lead to big of 1 because we'll be making use of only constant number of extra variables, nothing but, as I have said, the resulting variable, right? So overall space complexity would lead to big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of 1 respectively, right? So let's do one thing. Let's quickly discuss the complex this one. Let's start writing the code, man. So as we are completely familiar with the approach and the complexities, let's start writing the code, right? So first thing here would be let's initialize the result that accumulate to this one, or we can just call this one as result accumulator, right? So let's initialize result accumulator to 0, right? So this is nothing but the identifier for XOR. So this one will be int result equals 0. Next thing is we will be looping through every number in the array. So let me consider individual number of nums. So this is fine. So XOR the current number with the accumulator, and we'll be considering the duplicate numbers. So basically the duplicate numbers that cancel out because XOR X is nothing but 0. We know this one, right? So we have already discussed this one in the approach. Also the one last thing here would be the unique number remains, because 0 XOR unique is so it is always unique, right? So that is how we are making use of the bit manipulation here, right? So this one result XOR equals num. This one I have already showed this one every step by step, right? So we are left with only one thing, that is after processing all elements, result holds the single number, right? So all we have to do here is we have to return the result, right? So we are done with this part. Let me format the code once and let me hit the run button, right? So just give me a second. Yep, you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. I hope this works for all the test cases. Yeah, yep, it works for all the test cases, right? So all the test cases are getting passed here. So whatever the code that we have written works absolutely correct for all the test cases, right? Works absolutely correct for all the test cases, right? So this is fine. Now yep, we are done with the approach part. I mean, we are done with the problem, basically a solution. So whatever the, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.